Hi everyone, this is week 4, tutorial 2, and our first task today is about bisection method, where we will work on finding the zero of the function e to the power x minus 2x squared with the tolerance of 10 to the power minus 1, and we'll record the values of a, b, and x at every step, including the error, and we'll give 4 digits after the decimal point. So here we have our function written, and we will start first finding out the interval. So for the interval we need an upper limit for the interval and a lower value for x for the interval, and when you multiply with these two values inside the function, you will get a negative value. So that shows that there is a point which cuts the x is equal to 0 axis. So there is a 0 in that point or between that interval in the function. So let's consider maybe the values here. For the upper limit, let's consider the number 3. So if you have f of xu, which is f of 3, it will be e to the power 3 minus 2 times 3 squared, and this will give you the value as minus 0.3175. and then let's consider another value, let's say 2.5 here, and when you put this value inside the function, you get a value e to the power 2.5 minus 2 times 2.5 squared, and this gives you the value 2.0855. So now you can see we have got one negative and one positive value. So if we multiply now f of xu times f of xl, we get a value which is minus 0.3175 times 2.0855 will be equal to a negative value, which is minus 0.662144625, and this is less than 0, which means there is a 0 between these two values of the interval. So let's take our first interval 1, to be 2.5 to 3. So how do you find out this interval is 3, 2.5? If you try out random values where you get one positive and one negative number for the function. When you put the values in the function, you get one positive, just like I got one positive here and one negative value here. Once you get something like this, so you can work ahead with it as an interval. And now, if this is our first interval, let's say our a. So a is actually the xu. So if you do not want to write it as a, it's fine. So our a1 here, or you can say xu1, the first value, is 2.5, and then you have your b1 for the first interval. So I'm writing it as a1 b1 is 3. So let's calculate the error 1 now. So the error 1 will be b1 minus a1 divided by 2. So that is equal to 3 minus 2.5 divided by 2, which is equal to 0.25. So that's the error for this step. Now let's find out the x1 value, and that will be equal to a1 plus b1 divided by 2, which is 2.75. So now we'll again write all the values here, which is the interval values 2.5, 3, and this new value that we got between the two values of 2.5 and 3, which is 2.75 inside the function, and we'll find out our new interval. So let's put the value here in the function 2.5, and as you know from before, we get for this one here okay, I guess I did a mistake here, so yep, I did a mistake here. So for f of 2.5, you get here the minus 0.3175, and for f of 3, you get here 2.0855. So sorry for that mistake. So here for xu, these are swapped, so this will be here and that will be here value, and then everything else is fine. Okay, so now f of 2.5 is minus 0.3175, and f of 2.75 is equal to 0.5176, and then you have f of 3, which is equal to 2.0855. So now you need to find out for the next interval two values where it's changing signs. So here you have something which is less than 0, and then you have something which is more than 0, and then you have something which is more than 0. So where there's a change of sign is here at this place, where you have one negative number and then the next one is a positive number. So this would be our second interval. Okay, so if you multiply, or it's not about multiplying here, it's about organizing the numbers here in order, and then the two consecutive numbers where you see a sign change, in that one you say that that's my new interval now. So now we go for the interval 2 workout. So here we have here our interval 2 is now 2.5, and xu is 2.75. So now we have a2, which is 2.5, b2, which is 2.75, and then error 2, which is b2 minus a2 divided by 2. So here you have 2.75 minus 2.5 divided by 2, which is 0.25 divided by 2, that is equal to 0.125. Okay, so now we find out our x2, the next x value, which we get by adding a2 plus b2 divided by 2. So we have here 2.5 plus 2.75 divided by 2, which is equal to 2.625. And now we'll put them in the function here. So we'll take the first number is 2.5 in order, the next one is 2.625, the x value for us, the new one, and then the next number will be 2.75. so that's in order of numbers. And then if we put these values in the function, we get here minus 0.3175, which is less than 0, and then we get here 0.0233, which is greater than 0, and then we get here 0.5176, which is greater than 0. So here, where do you see the sign change consecutively? So you see it here, of course. So we have a negative number here and then a positive number here. So this is where our interval 3 lies. So let's work out with interval 3 now. And for interval 3 then, now we have the values 2.5 and 2.625. So now we again note down the A3 value, which is your L, and then which is 2.5 here, and B3 is 2.625, and then you have E3, which is B3 minus A3 divided by 2. Okay, you could also get the error more easier, like you don't have to do subtract every time. You can just take the previous error and divide by 2. So that also can be done. So I'll just show you once I'm done with this. So here we have 2.625 minus 2.5 divided by 2. So this will give you the value as 0.0625, or let me write it this way. So here, when you subtract both of these numbers, you get the value as 0.125 divided by 2, which is 0.0625. So this is actually the same number as this. If you see the value here, which is 0.125, is actually this value here, right? So what you can do is, you can just say for every time your error comes down, you can just, for E3, you could also just do like E3 is actually E2 divided by 2. So you have 0.125 divided by 2, which is 0.0625. The same thing you could do for E2. So you can calculate E2 is equal to E1 divided by 2. So E1 was 0.25 divided by 2, and you will get 0.125. So you could also calculate the error this way. Now we can again find out our x3 now, which is 2.5 plus 2.625 divided by 2, and this gives us the value as 2.5625. Okay, now one thing we have to see is, what did the question tell us? So the question was telling us that the tolerance is 0.1. So once the error is below 0.1, we can stop. So as you can see, 0.0625 is actually less than 0.1. In that case, we can already stop at this step. Okay, so we'll stop here, because according to the question, it says that the tolerance is 10 to the power minus 1, which is 0.1, and we already got an error which is less than 0.1. So we can stop here, And then we can say that our 0 for this function is approximately this value here, which is 2.5625. Okay, I hope that's clear.